Welcome to lesson 112 of algebraic concepts. Apply systems of linear equations. So now we're going to look at the purpose of doing systems of equations. We know we've been looking for the point of intersection, but how does that relate to real world problems? All right, here's our objective, our vocabulary, our rules and notes. Please pause this video and read through those things. They will be helpful to help you understand where we are going in this lesson. Okay, the whole point of systems of equations is to find the point of intersection if there is one. And you only get three possible outcomes. One solution, which is a point of intersection. No solutions, which means the lines never intersect, parallel lines. And then an infinite solution, which means you had the same line. All right, so here's our first real world example. Alan bought 5 pens, some blue pens for 70 cents each, and some red pens for 65 cents each. If he received $1.65 change from $5, how many red pens did he buy? So what do we do and how do we solve this? Well, let's see. What are we dealing with? We're dealing with blue pens and red pens. He bought 5 of them, but we don't know how many pens we have. We have blue pens that are 70 cents each. So 70 times a blue pen plus 65 times a red pen equals 5 minus $1.65. That's what we have, and those are all the numbers that are in this problem. So for 70 cents for each red pen and 65 cents for each red pen, 5 minus is 335. Oh, look, I got the same variables, so that means I have two systems of equations. And so now that we have to deal with decimals, how do we do it? So we wrote these as standard form of a line, so we can go ahead and solve it like it is. So these decimals are less than 1, and you know both of these variables are 1. So what I would suggest you do is either multiply everything by 0.65 or multiply everything by 0.7. It does no harm. So since 0.7 is easier to multiply by, that's what we will do. So rewriting everything under the line, at 0.7b plus 0.7r, 5 times 0.7 is 5 times 7 is 35, is 3.5. And put a 0 on at the end of it. And so you have 0.7b plus 0.65r equals 3.35. Now look, our b's, the coefficient in front of the b's are the same, so we're going to minus. We're going to change all the signs to negative. And let's add the equations. 0.7 minus 7 is 0, so they cancel out. 0.7 minus 0.65 is 0.05 equals 335 minus 15. 0.15 divided by 0.05 divided by 0.05. 15 divided by 5 is 3, so that means 3 red pens. But what do I always tell you? Make sure you substitute into both equations to make sure your numbers come out right. So 2 blue pens plus 3 red pens will equal 5. All right, that's that. So let's make sure it works in 0.7b plus 0.65 times 3 equals 335. 0.7b equals 0.65 times 3 is 195. Because 3 6s are 18, 3 5s are 15. $1.80 plus 15 is $1.95. Let's just check. That should be right. But let's put it into our calculator. It's $1.95. Plus $1.95 equals $3.35. Minus $1.95 from both sides. 0.7b equals 0, 2, 3, 4. $1.40 divided by 0.7 divided by 0.7. B equals 14 divided by 7 is 2. So you get 2 for B in both situations. So Alan bought 2 blue pens and 3 red pens. And there you go. This is a use. Okay. 2 river towns are 60 miles apart. 60 miles, 4 hours with the current. Okay, so what do we got? The boat takes 6 hours traveling against the current. What is the speed of the boat and the speed of the current? Okay, so let's see. So B is going to be speed of the boat, and then C is going to be speed of the current. And so now what do we have? We have, with the current, we have B, the boat plus the current, it gets 60 miles. And this takes 4 hours. Okay, against the current, so B minus C, the distance is still the same. And so why do we have B plus C? Because B plus C in the first equation is the boat plus the current. And in the second equation, traveling and against the current. So you had to subtract the current because the current of a river does have speed. Current is the movement of a river. So it's boat minus the current. So now we got to distribute the 4 only to the stuff inside the parentheses. So you get 4B plus 4C equals 60. And then 6B minus 6C equals 60. And so now what do? We got 4 and 6 on both. Okay, so we are going to have to multiply. So running through our force, 4, 8, 12, 6, 12. All right, 2 and 3. Multiply this one by 2, multiply this one by 3. You get 12B plus 12C equals 120. You get 12B minus 12C equals, this is 180, I'm sorry, 180. This is 120. And so now, look, we can add 24 boat will give us the speed of the boat. The current drops out. 180 and, what is that, 400? 300. Divide both sides by 24. Divide both sides by 20. B equals 300 divided by 24. So it's going to be 5. It's 12.5. Okay. So we have 12.5 for B. Now what we have to do is go back and stick this into both equations. And so 4 times 12.5 plus 4C equals 60. 25, 50. So 50 plus 4C equals 60. Subtract 50. Subtract 50. 4C equals 10. Divide by 4. Divide by 4. C equals 2.5. All right. Now we solve for the speed of the boat, and now we have to make sure it works in both equations. All right, 6 times 12.5 minus 6c equals 60. I'm trying to write small here, so my handwriting it may get a little sloppy. 6 times 12.5, 6 12s is 72, 6 5 is 30, so it's probably going to be 75. 75, all right, 75 minus 6c equals 60. Subtract 75, subtract 75. Negative 6c equals negative 15. Divide by negative 6, divide by negative 6. 15 divided by 6 is 2.5. So the speed of the current is 2.5. The speed of the boat is 12.5 miles per hour. Do not forget our variables, our units, our units. And the speed of the current is 2.5. So with applying systems of equations, we had to do a little thinking. Okay, how much pure bleach and how much of a 20% bleach solution must be mixed to get 4 liters of a 30% bleach solution? All right, so, all right, this is, what are we going to do? How are we going to do this? All right, so pure bleach, let's call this PB. PB equals 100%. And then you get a 20% bleach, and then a 30% bleach, and you get 4 liters. All right, so these are the numbers that we're dealing with. So how do we put all of these things together? So we got pure bleach, let's call it X. Because we want to get a 30% bleach solution. Pure bleach plus 20% bleach will give us 4 liters. And 20% bleach solution. So if we made X pure bleach, then Y must be the 20%, 0.2. 20% as a decimal is 0.2 will equals a 30% solution, but we need 4 liters of that 30% solution. So what do we have? X plus Y equals 4, and then X plus 0.2Y equals 1.2. Okay. So now, since we have the x's had the same coefficient, what we're going to do is subtract the equations. So when we subtract, change all of the signs, and then go ahead and add them. X plus negative x is 0. Remember, the 1 is here. 1 minus 0.2 is 0.8. 4 minus 1 is 3. Minus 0.2 is 2.8. And we divide both sides by 0.8. And that's going to get a little tricky. So remember, Y was our 20% bleach solution. Pure bleach was X, 20% was our Y. 2.8 divided by 8. Equals 3.5. So Y was our 20% bleach solution. Y should be 3.5 liters, which tells us that X plus 3.5 equals 4. So we should get half a liter. This is a chemistry thing. So if you're doing titrations in chemistry, this is what you'll have to figure out. All right, now we have to make sure it works in both equations. 0.2 times 3.5. 35 double up is 7, so that should be 0.7 equals 1.2. Subtract 0.7 from both sides. X equals 0.5. All right, so that is correct. So in order to make a 30% bleach solution with 20% bleach and pure bleach, which is 100%, you'll need 3.5 liters of your 20% solution. 3.5 of, that should not be equals, that should be of. And then 0.5 liters of your 100% solution. So those were our 3 examples. Please try to practice problems, and I will see you at the end of the video for a recap. Okay, so let's look at what we have here. Brianna has money in dimes and quarters. So how much is a dime? A dime is 10 cents for each dime plus 25 cents for each quarter equals $3.30. Okay, so whenever you're dealing with monies like this, one of your equations is going to have a money in it. And then the other says the number of dimes is, the word is means equals, 3 fewer than twice the number of quarters. 2q minus 3, because fewer means subtracted from. So now what I'm going to do is put this in for dimes. So we're going to substitute in for dimes. So we got 0.10 parentheses 2q minus 3 plus 0.25q equals 330. Okay, so 0.10 times 2 is 0.2q minus 0.3 plus 0.25q equals $3.30. Add 0.3. Add 0.3. 2q plus 0.25q is 0.45q equals 3.60. Divide both sides by 0.45. Divide both sides by 0.45. Q equals 36 divided by 0.45. If you double 45 up, that's 9. That's 4. 36 divided by 9 is 4. Half of that doubled up is 8. So you got 8 quarters. Okay, so we got 8 quarters. Now we have to check the quarters. Dimes equals 2 times 8 minus 3. 16 minus 3 is 13. That's the number of dimes. I got to check in the other equation. 10D plus 0.25 times 8 equals 3.30. 0.10D plus 8 quarters is $2 equals 3.30. Subtract 2 from each side. 0.10D equals 3.30. Divide by 0.10. Divided by 0.10. 33 divided by 10. By 130. 2 minus 1 is 130. 130 divided by 10 is 13. So it works both ways. So another way you could have done this is to, that dimes are 10 cents and quarters are 25 cents. What you could have did was just did, all right, 1 dime, 2 quarters. So you could have set up a chart, dimes, quarters, and total. And then 1 dime, 1 quarter is 35 cents. And then, 10 dimes and, 5 quarters. 5 quarters is $1.25. So that, and then 10 dimes would have given you another $1. That would have been $2.25. So you could have played around with the numbers like that until you got what you wanted. So there's all kinds of ways to solve math problems. Okay, in 5 years, Nick will be 3/4 as old as his cousin. So Nick, in 5 years, will be 3/4 of his cousin plus 5. Okay. So let's do some algebra. Nick plus 5 equals 3/4 C plus 15/4. Okay, so let me show you a little trick here. When you're dealing with fractions, you can get rid of fractions by multiplying by the bottom. Since both of these have a denominator of 4, if I multiply by 4, then those bottoms go away. But remember, you have to multiply the entire thing by 4. So if I subtract 20 on both sides, I get 4n equals 3c minus 5. So I get 4n minus 3c equals -5. Okay, now that's the first half. 3 years ago, Nick minus 3, he was half as old as his cousin. Half his cousin minus 3, because they're both 3 years ago. And so now I'm going to do the same thing. Nick minus 3 equals 1/2 C minus 3/2. And then I'm going to multiply this entire thing by 2. So you get 2n minus 6 equals C minus 3. Then I'm going to add 6 to both sides. And so get 2n equals C minus 3. Plus 3, I'm sorry. And subtract C. 2n minus C equals 3. Okay, so now let's look at our two equations. You get 2n minus C equals 3. I'm going to multiply this one by -2. So that would be 4n minus 3c equals -5. So both of these are coming over here. And -4n plus 2c equals negative 6. If I add them both up, I get negative 1c equals negative 11. So the cousin is 11, but I don't know that for sure yet because now I have to go on and put these numbers in to my equations. But I'm not going to go back into the original equations because I don't feel like dealing with fractions. I am going to go into this equation here and this equation here because the math, well, this equation because the math was already done. Okay, so let's start with that one. So if the cousin is 11, how old is Nick? For Nick equals 3 times 11 minus 5. 33 minus 5 is 28. 4 times Nick divided by 4 divided by 4, and Nick equals 7. Okay, let's check and make sure that that's right. So 2 Nicks minus 11 equals 3. Add 11, add 11. 2 Nicks equals 14. Divide by 2. And Nick equals 7. So Nick is 7 and his cousin is 11. Okay, so let's look at our last example. Alma invested $4,000. She put one in the certificate of deposit, so let's call that C, and paid 5% annual interest. And the rest in the money market that paid 7% annual interest. All right, so what are we going to separate that? Interest for 1 year is $248. So annual means 1 year. Okay, so certificate plus a money market equals $4,000. Okay, so what we had to do separate here was the money from the interest. So then you got how much interest? 5%, which is 0.05 on a certificate, and she pays 7% on the money market equals $248. Or the 248 is the interest, so that had to match the interest equation. And then the money, the straight money, works out. So you got C plus M equals 4,000. And then 0.05C plus 0.07M equals 248. And what we're going to do is multiply this one by negative 0.05 so that we can add the equations. So you get negative 0.05C minus 0.05M equals 4 times 0.05. Is that 80? Is that 800? All right, doing the math on that, it comes out to 200. And then you have 0.05C plus 0.07M equals 248. And once you add these equations together, same signs add, different signs subtract, you get 0.02M equals $48. Divide by size by 0.02. Divide by 0.02. And the money market was 2,400. Okay, this is what we solved for. So let's see how much and if it works out. So C plus 2,400 equals 4,000. Subtract 2,400, and the C will equal 1,600. Okay, let's make sure it works in the other equation. 0.05C plus 0.07 times 2,400 equals 248. 0.05C equals where were we? 0.07 times 24 is 168 equals 248. 0.05C, we had to subtract 168 from both sides. That gives us 248 minus 168 should be 80. Dividing both sides by 0.05. C will equal, voila, 1600. Okay, so in the certificate of deposit, she put 1600. In the money market, she put 2400. It has been verified. This is why people do not like systems of equations, is because you have to check your answer in both equations. You have to do it all. If you don't do it all, your answer may not be right, or you may have made a math mistake somewhere. You have to make sure that once you isolate the one variable, it works in both equations for the other variable. You get the same number. And that's the trick with doing systems of equations. That concludes this video, and I will see you on the next video. Thank you for watching.